Hello, good afternoon. Me, Estefania, and my teammates, Rodrigo, Emilio, David, Caro, and Marce, we're going to present the activity 1.1.
The objective for this experiment is to study the energy at its first level and its transformation by using lemons, wire, zinc, and cables.
Chemical energy is present in fruit, which is later converted to electrical energy.
The acid found in lemons is citric acid.
The citric acid in this experiment works as an ionic solution so that the electrons found in the zinc wire can go easily through the solution into the copper wire.
We gathered 4 lemons and put a copper wire into each one of them and a zinc wire, and so creating the electrodes for each lemon. Then we grabbed the alligator cables and then we linked them up all together. That way we can create a circuit to make like a small battery. And so if we connect them all to a LED, it will turn on.
We may not be appreciate the light right now, but it do turns on.
De hecho creo que ya apúntale así directamente y me avisa si se ve cómo se prende.
Sobres. The lemon is similar to a car battery in which both of them, the oxidation and reduction reaction happen. It is also similar to the first battery that existed, which used bright water by Alessandro Volta in
The function of the metals is that they work as electrodes. The force used is electromagnetism, because that's the reason all electric devices work.
In this experiment, we built a lemon-powered battery, which purpose was to light an LED. We took zinc and copper wires and stuck them into each lemon. We researched the purpose of the wires and what type of energy was used to light the LED. It was chemical energy transformed into electrical energy.
For the second experiment, we'll be using 30 dice and 25 coins. This for us to identify and study what is the weak force by using probability. For the development of this experiment, we'll be using coins, representing coinium, in order to represent the atoms. When we throw them all, which is gonna happen, when the coin ends up hitting tails, this represents coinium is unstable. But when it gets heads, this means it's gonna be stable. We're gonna throw them all and we're gonna attempt and we're gonna get all of them heads up. For dices, which will be representing dicinum, this works similarly, but the unstable part would be number 6, and if any other number appears from 1 to 5, this would represent a stable atom. So we're gonna throw them all, and after that we're gonna try to see in how many attempts do we get all stable dices.
Half-life refers to the time it takes for a substance to be reduced by half by decay, therefore the emission of radiation.
This dice activity was an example to teach us how to understand the beta decay, which involves the change of a neutron into a proton.
Through this experiment, we created 4 graphs to help us understand the results. With the coins, we spent 5 tosses to get all atoms to decay, which compared to the theoretical graph of probability, it should have only taken us 2 tries, taking into account that probability in this case is of a 50%. With the dice, we spent 4 tosses to get all atoms to decay, which compared to the theoretical graph of probability, it should have taken us 6 tries, regarding the fact that the probability for a die to land on a 6 is of a 20%.
The probability for the coins to come with heads up is 12 out of 25, or 12.5.
The probability of a single dice heading up 6 is 5 out of 30.
The decay of radioactive material is a random process, kind of like flipping a coin or a die.
During this experiment, we could observe how does a weak nuclear energy works by relating probability to radioactivity. We use dice and coins to observe their similar behavior to decayed and undecayed atoms.